This episode is brought to you by InterTrust Technologies and Modulus, helping you build data-driven businesses. Modulus is a data rights management platform that lets you manage multi-party data securely across any cloud or infrastructure, allowing you to break free from silos and build commercial data exchanges. With Modulus, you are always in control of your IoT data. Go to intertrust.com for more information.
Welcome to Tech Lightning Rounds. I'm your host, Beth Kindig. This podcast interviews key people with deep expertise on one topic for a 360-degree view. One difference between this podcast and the other podcasts you listen to is that I hold short interviews called Lightning Rounds, with the goal of getting you a lot of compelling information very quickly so you can get on with your day. The energy industry is undergoing an important transformation driven by the introduction of renewables, deregulation, and increased attention to climate impact. This shift is further fueled by the internet and new advances in cloud computing, IoT, and big data. In this episode, I speak to the company Chevron, where technology is being leveraged in transformative ways, including with drones and augmented reality.
And what's amazing is a process for collecting data, which used to take multiple people going down into a tank to collect the data. I can now send a drone in and have it send data to the people outside of the tank.
I also speak to Innogy Ventures, a company that has been supplying central power for over a century and is making strategic investments to take on the next era of decentralized power production.
Now the next mega trend and also challenge for this industry will be electric cars. Driving an electric car is great, but you need to charge it. So where are the electrons coming from? Well, the electrons come from the energy system. And the amount of additional load that is put on the local infrastructure via electric cars is very, very significant.
And I speak to Schneider Electric on what is involved with distributing power for edge computing.
So we have applications from data collection and content delivery at the edge with IoT kind of emerging and millions of IoT devices proliferating. The need to move power from centralized out to the edge is a big challenge.
Chevron is one of the world's most recognizable names in oil and energy, with a presence in over 180 countries. In this first lightning round, I speak with Michelle Pflueger, General Manager of Digital Innovation and Acceleration, on the many ways that Chevron is using technology to lower costs and increase output. The first project we discuss is called the Gorgon Project, which uses advanced engineering to maximize production and distribution of natural gas, which is typically inconveniently located farthest from where natural gas is needed. You have a project called the Gorgon Project, and what have sensors and advanced process controls done to contribute to value there?
So what's amazing is sensors now are everywhere. If you look at what's happened over the last few years, the price and availability of sensors has dropped. We have over 1 million sensors across Chevron right now. We expect that over the next 5 years, we're going to see that to grow at a rate of at least 100,000 sensors per year. What we can do with this data, especially given the changes in cloud technology, the changes in artificial intelligence, machine learning, is amazing. When I look at advanced process control, and if you're not familiar with advanced process control, think of it like adaptive cruise control on your car. And we can now put that on our plants. We've been doing it for years in downstream, but with the rise of sensors, you can do it even more. For example, in our LNG facility in Australia, we were able to use advanced process control to create $240 million of value in 2018. That's huge. When you can do that again across all of your big plants, it makes a huge value difference.
Can you give us a little bit of background about that project? What is it exactly, and why did you initiate that project?
That project, so LNG, liquefied natural gas, it's a way of moving energy across the ocean on boats. We have a very big plant in Australia. And one of the things we found is similar to your car. If you can run your car with cruise control, it gives you more control. It allows you to stay within the control limits, the speed limit. With adaptive cruise control, which some of us have on our new cars nowadays, it allows you to sense the car that's coming in front of you and automatically slow down. When you can put that sort of control on a big facility, it allows you to run it safer. It allows you to run it more reliably. It allows the operator to have more control of the plant because they're focused on the one-offs when an anomaly happens. It allows the plant to run much, much smoother and safer. And by having a smoother and safer running plant, you can get more throughput out of the plant, which translates into more value.
Most companies today are data companies. What kind of data do you use to improve operations? Like, what does that look like?
So, it's funny. I've been with the company for 19 years, and for 19 years, I've seen that Chevron is a data company. When you look at our fields across the world, in Bakersfield alone, San Joaquin Valley, we have thousands of wells. So we have always tried to collect as much data as we could on our wells, but that expands much beyond wells. If you look at our entire value chain, if you start from the rock itself, we have sensors that are down inside the wells telling us how the wells are producing, how the fluid's producing. We've got sensors at the surface telling us about our pressures, our temperatures, acoustics, the sounds. That goes on to the pipelines. It allows us to make sure that we are moving our fluids safely and effectively. That goes all the way into our plants and then our refineries and then even our point of sale. We are collecting data on absolutely every aspect of the facility. It allows us just loads and loads and loads of data and information which we can bring together to do advanced analytics. One amazing example, we have big compressors that help us compress our gas, whether they be offshore or onshore. We now have a center in Houston and a few others around the world which take that data in real time, analyze it, and let the fields know if they see an anomaly. So we can actually take the equipment down before it breaks. It's like getting a warning light in your car, except we're doing it on big equipment. We saved $40 million last year monitoring our machines.
Chevron might not be the first company you think of when it comes to augmented reality, but as Michelle explains, energy companies perform complex and high-risk maintenance and installations in places where drones and AR can be leveraged. And do you use drones at Chevron?
Yes, our digital program spans lots of areas of technology, like I mentioned before, artificial intelligence, machine learning, industrial Internet of Things. Drones and robots are another big piece. We recently showcased one of these really cool drones, which you can actually use inside of a confined space. So by confined space, I mean inside of a tank or a vessel.
Do you have any examples on augmented reality that you can talk about, or?
Oh, yeah. We have probably the coolest one I've seen is through our partnership with Microsoft, and it's called the HoloLens. The HoloLens allows you to be out in the field, and I want you to think of a field location. Offshore, you're out in the middle of essentially nowhere, and you put on this HoloLens, and you're paired with a person back in Houston who's also wearing a HoloLens. You, out in the field, can be looking at an piece of equipment, and the person back in the office can see what you see. And when they point their finger in front of their HoloLens, you can see their hand coming out in front of you. And they can pull up an instruction manual, a repair manual, and it shows up in front of you. So you can have somebody out in the field troubleshooting in a piece of equipment, getting real-time support from one of our subject matter experts that's sitting back in Houston. No need to fly offshore, no need to worry about visas and travel. You're able to get that expertise real time through these basically augmented reality goggles.
In the next interview, I speak with Florian Kolb, the Managing Director of Innovation and Investments at Innogy, a subsidiary of RWE, a company that was founded in Germany around the same time that Thomas Edison brought electricity to New York around the turn of the century. Florian and I chat about how Innogy came to Palo Alto 4 years ago to secure new technologies and what the venture firm is doing to maintain a competitive edge in a decentralized world. Globally, what are the energy needs in the regions where you invest? Can you tell us, like globally speaking, what do you see going on with energy, whether that's Europe, Asia?
Yeah. So the reason why after 110 years we need innovation is what's happening right now across the globe, in the US, in Europe, in Asia, is a move from a very central energy system, very centralized energy system where you have huge factories that produce a lot of electrons that are connected to thick cables that then ship the electrons via cables that are getting smaller and smaller as when you come to the end customer and then sell them to end customers. That's the old model. This is shifting rapidly to a decentral model where you have renewable generation on rooftops or community solar or industrial scale solar or wind farms that are just everywhere. Now this old model doesn't work anymore. And I think you can, on the distribution side, so electricity grids, this is like you have a one-way street and everybody knows it's a one-way street. And out of a sudden you have two-way traffic. So because in the electricity case, the electrons, they don't go only from A to B, but now they also go from B to A and from B to D. And so that has changed the landscape dramatically. And it's a big challenge. Now the next mega trend and also challenge for this industry will be e-mobility, electric cars. Driving an electric car is great, but you need to charge it. So where are the electrons coming from? Well, the electrons come from the energy system. And the amount of additional load that is put on the local infrastructure via electric cars is very significant. So now the question is, how can we enable e-mobility that people can charge the cars when they want to charge them and when they need to charge them without producing massive problems, blackouts, hardware blowing up, which by the way happens already. Also in the Bay Area, there are some nice videos on YouTube where you see like these the stuff that's on a pole blowing up because you had 5 guys showing up at 6 o'clock plugging in their Teslas at the same time. That's a very visible example of the problem. And you have e-mobility push in China, you have it in Europe, also in the US. Customers will demand these cars. And the system has to somehow deal with that. And that's great for innovators because it provides global opportunities. And if you look also to the startups from the Bay Area that are trying to develop software-based solutions for some of these problems, then they almost all of them have a global ambition. Because the technical challenges and also the infrastructure challenges are pretty much the same around the world. Because electrical systems are designed in a very similar way around the world. It's not like, people in Japan doing their system in a completely different way than in the US or in Europe. The principle is always the same.
Florian and I discuss some of the issues that energy companies face due to massive amounts of fragmented data that is being generated now, and why data interoperability is essential for the future. How is data informing energy infrastructure?
Yeah.
Can you give us a few examples?
Sure. So, that's why we came up with the idea of data-driven business models, because if you look to energy systems, they are very data-rich. There's a lot of data coming from the hardware in the field. So just picture a wind farm. Each of these wind turbines has hundreds of sensors that produce massive amounts of data. Then you have grids. You have a lot of sensors in the grids these days. They produce a lot of data. Then you have consumers that have connected devices in their homes or a car that is connected. If you have a Tesla, it produces data all the time, what you're doing, where you're going, when you're charging. So there's a massive amount of data that is produced by the system. Today, There's really no very easy accessibility of this data, end-to-end management of the data, because you have different value chains with sometimes different owners of different segments of the value chain. So it's a very fragmented data space. It's not like Facebook, where Facebook has all the data. Yeah, and they can do a lot of things with it because it's in one hand. Here it's completely fragmented. So the interoperability technology from Intertrust is very helpful to break up the silos in a way that people feel comfortable with the silos being broken up. Because you need to share data with others, but you need to ensure that you still keep the ownership. You don't want other people to walk away with your data. That needs technology to secure that, and you want to know who gets access to your data. So you need to have digital rights management in place. Now, the reason why we invested is because they are very knowledgeable and very capable of enabling the monetization of digital assets. They have proven that in other verticals like entertainment media. And that's where typical in the past you found monetization models around digital assets. And what we found out is that we can use the same technology that works for an app store, like an Apple App Store or Google App Store, to monetize digital assets, also for data assets that we own and operate. Yeah. So things like data interoperability, trusted data management, secure data management are things that are very important for us because we operate critical infrastructure or we own customer-related data assets which need to be protected. But in order to unlock the value that is in the data, you need to have these technologies in place. So that has developed very, very nicely. I think it's the biggest success story that our company has. Why? Because we took the technology, we incubated the technology around the energy vertical, which is where we come in, where we have certain expertise. And then out of that, we developed new products, which we tested with customers, of course, and turned that, in some cases, into new business.
What will IoT connections do for the energy space? What are you most excited about here?
Yeah, I'm most excited about that we get more data and more connectivity. So let's say in the old world, you had a TV, you had a fridge, you had an oven, you had appliances that were not connected. In the future, they will be connected because the device manufacturers simply connect everything. I was at CES, there is a connected toilet, there's a connected bath tube, everything is connected. And it will take time before these things will penetrate the homes, but it will come because it will just be a built-in feature. So this means you get more and more information about usage of energy. And that's what we are interested in. We don't try to socially profile people. For example, what they watch on the television, that's relevant for other people, not for us. We would like to know, when do people use electricity? Because with that information, we can help stabilize the energy system, which is under this enormous amount of pressure because of this shift from a central to a decentral system. And I think the biggest lever is with cars, with electric cars, yeah, because they demand the most load. So in this transformation, this explosion of IoT sensors and also IoT data, I think will at the end help us to have hopefully a more reliable, a cheaper, a more efficient, a better energy system in the future.
In my last lightning round, I speak to Steve Carlini, Vice President of Innovation for Secure Power Division at Schneider Electric. Schneider is another company that was founded nearly 100 years ago in France with over 20,000 patents and large investments in R&D. Stephen and I talk about what Schneider is doing to prepare for the design and deployment of edge computing and how Schneider is positioned to power micro data centers for 5G. Can you put into context how the demand for power is increasing How is our current electrical system up to par or not up to par for demand?
So I think IT is driving a lot more of the power needs going, and it'll drive a lot more going forward. Currently, it's about 2% of the worldwide demand for power, and we've seen forecasted going up to 8 or 9%. And a lot of that is being driven from edge applications. So we have applications from data collection and content delivery at the edge, with IoT kind of emerging and millions of IoT devices proliferating. The need to move power from centralized out to the edge is a big challenge.
Yeah, exactly. So from a power distribution point of view, what will micro data centers do? Will they increase power consumption?
So in the past, you've had like a lot of factories, a lot of big industry that's located closer to substations. So they're strategically located where the power is. As things move out, an example would be like a farm that's implementing, IoT management system for agriculture. So they're going to be deploying thousands of systems. They're going to have a data center there. So they may need, 10 megawatts of power at that site where they, may not have needed that in the past. So there's a need to beef up the power distribution towards the edge of the power grids. So we're seeing a lot of that today. And with applications like 5G coming, where we're going to have to deploy hundreds of thousands and even millions of these micro data centers globally, it's going to be a tremendous challenge to bring enough power to those edge sites.
Just dialing more into making 5G micro data centers more efficient, can you give me a comparison with the level of power consumption we have now versus how that will look with 5G in the future?
Sure. So with 5G, like I said, we're going to have to deploy micro data centers at scale, and we're involved with projects, for 10,000 pieces of micro data center. So if you take say an application or a deployment that's 2,000 pieces, and say each one of those is 10 kilowatts. That's 20 megawatts of power. So, we've had a lot of experience in larger data centers, making those as efficient as possible and refining them over the years. So with micro data centers, it's a little bit different. It's more of a design challenge than a kind of a deployment and then tweak it and optimize it. So you want to do an integration of the power, the cooling equipment. You want to use, the enclosures for the environment. You want to use the latest battery technology, and you want to use the most innovative cooling technologies in these designs. So, the result would be a design that's, optimized to be able to deliver the application as efficiently as possible. And we also have advanced software tools now that we're using to gauge the performance of those data centers. Now, when you have that many data centers deployed, thousands of data centers deployed, it's very impractical to have the data center management systems, on site. So we have cloud-based systems now. So we're taking the data from these micro data centers, and we're creating a simple and easy access point to the cloud, where you could look at all of your micro data centers together and see if they're operating at the optimal efficiency and the efficiency that they were designed to do, and if there's any problems that arise. So it's a whole new type of approach to data center management, going from like one data center with hundreds of thousands of access points to the access points being distributed to many different locations.
Stephen and I continue the discussion on 5G and what is involved with the global rollout and what this will look like with a more open architecture. What does the global rollout look like for Schneider? Will you primarily be putting the micro data centers in Europe or the United States, or what's the rollout plan for data center architecture globally?
Well, 5G is actually interesting because it's a new architecture that's relies heavily on a data center architecture. And the old telco was kind of a country club. It was very closed. There was the carriers and then the telco equipment providers. With 5G, it's more of an open system. And with an open system, there's a lot of deployments of these MEC data centers. The IT part of it is actually kind of standard servers, or white box type servers, or whatever you want to call them. So it opens up this 5G architecture for more players. Like the traditional IT vendors are now looking for a way in to participate. So Schneider's we're dealing with the traditional telco, we're dealing with the traditional equipment providers, we're also dealing with the IT providers, we're also dealing with the cable TV kind of companies that are trying to also get involved with the 5G rollout. And then you have the internet giants. And the internet giants are all looking at, hey, the telco providers are not really that experienced with deploying, these data centers at scale. So maybe it's something we could do to break into this market, because, the market, the projected rollout's is estimated to be over $300 billion of equipment. So everyone wants a piece of it, and Schneider's perfectly positioned, because we're here to support, across the board, anyone that wants, to have a stake in the game. What I didn't really mention was, the initial rollouts could actually be LTE advanced, or they could be, 4.5. Some people are calling it 4.5G. And the reason that will work with 5G is because the software is disaggregated from the hardware. So you could deploy a 4.5G application now, and that's what, like AT&T is calling 5GE, and some people are calling it, pre-5G. So the speeds are going to get a lot faster as we roll out these new micro data centers. And then when the 5G software is more readily available, they'll flip it over to the new 5G software.
Thank you for listening to Tech Lightning Rounds. Please support the production of this podcast by subscribing in iTunes and leaving a review.
This episode was brought to you by InterTrust Technologies and Modulus, helping you build data-driven businesses. Go to intertrust.com for more information.